Today video I am going to show you that Lewis structure, geometry and bond angle of a compound. So first, to determine that Lewis structure, you need to count that steric number. So you can also see that whole whiteboard I draw a lot of structure. So this is just a common concept. So before going to that Lewis structure, you need to know that steric number. Then we will go that geometry and the effect of that lone pair. So first, to determine that steric number, you need to know that single bond is count as 1 and double bond also is count as 1, triple also count as 1 and lone pair also count as 1. So to determine that steric number, I can give you an example, right? So we already know that structure of water molecule, right? So in that water molecule there is 2 single bond, right? So 1, 2 and 2 lone pair, 1, 3, this is 4. So 1, 2, 3, 4. So this number are count as steric number. So any kind of compounds like ammonia, you can see that structure. So ammonia has 3 single bond, right? Single bond which will count as 3 and 1 lone pair which will count as 1. So ammonia also have like 4 steric number. Okay, so when we count that 4 or any steric number, then we can go through that general topics and we can go through that Lewis structure, geometry and bond angle of any compound. Okay, so in this video I'm going to show you specifically this compound SeCl6 and its Lewis structure, geometry and bond angle, and you can see that bond angle is depend on their lone pair. Lone pair have an impact on bond angle, so you can see that impact on that video. So let's begin. That valence electron you need to be more fast counted. So you can see that selenium has 6 valence electron and chlorine has 7. So 7 multiplied by 6 because there is 6 chlorine and it will make it 48, right? This 48 is the valence electron of that compound, and then we need to figure out their Lewis dot structure. So before go to that Lewis dot structure, you need to find out that least electronegativity of that compound. So you can see that selenium has 2.55 and chlorine has 3.16. So selenium has the least electronegativity. So you can see we need to point that selenium in the middle because it has the least electronegativity. Then we need to point that valence electrons which is 6 around that selenium. So I'll go like that. So this is 4 and this is 6 of selenium valence electron. Then I am going to put the 6 chlorine around that selenium. So I need more space here. So I'm going to remove that number and also that one. So then you can see that chlorine is here, 1 chlorine here, another here. So I set up 4, I left 2 and I can set up here. So you can see that chlorine has 7 valence electron and I can set that 7 valence electron this, and then I will put that, first I need to put that things here. After that we can figure out their Lewis structure. So this is your Lewis dot structure, but you need to figure out their bond, which one is going to which one. So then I'm going to figure out that one. Okay, so it will bond with that one, then it will bond with that one and that one and that one, right? So there is still one left, so I will make that one not here, make that one here and that one here. Okay, and this one left, So that we can put that one. So I'm just redrawing. So you can redraw that one and that one. So you can see there is no lone pair on that central one. So if you redraw that structure, it will be like that: chlorine, 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 and this two chlorine is here, and there is no lone pair. So this structure is that. Then you need to figure out their steric number. So there is 6 single bond. That means there is 6 steric number, right? And this steric number, then you need to match with that table. You can see that table I already drawn. So steric number 6 is here, right? And we don't have any lone pair electron. So 0 lone pair electron, it will be octahedral. So this structure, right? So for 6 steric number, sorry, 0 lone pair, it will be octahedral. And also you can see their angle, which is 90 degree. So now you can see there is no impact on lone pair on that structure because it has no lone pair electron on that central element. Okay, so in this video we figure out that Lewis structure, then geometry is octahedral, then bond angle which is 90 degree. I think you got that.